Hi guys, welcome back. Today we're going to be going back to the Autodesk Help website to build our first plugin. To get started, we're going to make a Hello World program. In the world of programming, Hello World is typically the first thing you do, and then you can start to increase complexity with plugins that actually do things. And we need to create a new project, add references, change the class name, write the code, and debug the add-in. Sounds like a lot, but don't worry, I'm going to take you through all of these steps. So first thing you have to do is to launch Visual Studio. And we are actually going to be creating a brand new project today because in the last lesson, I showed you how to make a new project, but we selected the wrong .NET framework. Today, we're going to be starting at creating a new project. You should already have Visual Studio installed. If you don't, please watch episode 2 where I walk you through the installation. So if you scroll down a bit, you should see a class library that targets the .NET framework, not the .NET standard like I showed you in the last video. That was my mistake. And we want to target .NET framework 4.8.1 because that's the one that will target the latest version of Revit. Click on that. You do have the option to place the solution and project in the same directory. Regardless of which one you choose, your code is going to run. It's just about preference. Next thing we're going to do is click on create. All right, so we're ready to go. Let's go back into our Autodesk Help website and see what we're supposed to do next. Okay, it's time to add references. If you remember in the last video, I asked you to search for your Revit API and Revit API UI.dll files. Well, now is the time to add them to the project. If you don't have a Solution Explorer visible, if you go right into the View menu, the Solution Explorer is the very first thing there. You can also access it with Ctrl-Alt-L, and it's really important to have your Solution Explorer. It has your plugin, your properties, your references, which is where we're going to add the Revit UI and Revit API DLL files, and your class name, which we're going to address later. Great. So now that we have our Solution Explorer, let's go ahead and start adding references. So to add your references, which is basically creating a link to the Revit API in your Visual Studio IDE environment, without this link, you can't really say you're accessing the Revit API. So you right click on references and you see an option to add reference. Now this is going to show you all of the references on your computer, and a lot of them are Microsoft based because interestingly the whole Windows framework, Microsoft Windows is a C#.NET framework as well. So you could just make applications for Windows, but that's not why we're here. We're making applications for Revit. So you'll find that you don't see any Revit API files here. So we need to browse. If we go on browse, we need to click on the other browse button at the bottom to go back into our Revit installer folder, which we looked at in the last video. So we're going to navigate to where we had the DLL files in the last video, which would be your C drive program files, going to the Autodesk folder, go into your Revit version that you are creating the plugin for, very important, and then scroll down to find the Revit API and the Revit API UI.dll. So I'm going to select both of them. If you have the option of having check marks on your computer, you could just tick them, or you could hold Control to select the two of them. Honestly, it doesn't matter how you select them. You could do it one by one or both at once. It's fine. I will say though, be careful because there is Revit UI DLL and Revit UI API DLL. Do not select these two. What we want is the Revit API.dll and the Revit API UI.dll. And then you click on add and your references are there. Perfect. You can see that your references have now been updated with those two references. So now we can start coding. The next thing we have to do is to set the copy local property of our Revit API to false. The reason why you do this is to save disk space. So I've tested this out. If you forget to do this step, what will happen is every time you create a new plugin, you're going to be copying all of the Revit API into the directory where you've created your file. So instead of just having the plugin you created, you're going to have basically the whole back end of Revit in the same folder. And if you do this a couple of times, trust me, you're going to run out of disk space. And that's what the warning is here. So we're going to go back to Visual Studio. Right now, I'm not able to view the properties of my Revit API so that I can update the copy local feature. We're going to go into the View tab and open the Properties window, or press F4 on the keyboard to access it. And there we have it. So in the Properties window, which you can dock anywhere you want, but I'm used to having it at the lower right at the bottom just here. So where it says copy local, which is like copy the whole Revit API every time I make a plugin, I'm going to change that to false. I'm also going to do the same thing for the Revit API UI, change copy local to false. And we're just about ready to start. So the next thing we need to do is to add the following code to create the add-in. Now, I know that if you've seen my other video where I walk you through the structure of a C# Revit API code, we're missing a few references here where we need to call on the Revit API. Now, usually with Visual Studio, as soon as you start coding, it's going to pick the references you need. So as soon as we implement the code that we can see on that website, we're going to actually see this update. So keep an eye out for that. This is the code we need to get started. First, we need to implement the IExternal command, which, if you remember, it is the command that runs in the add-ins tab of Revit. The iExternal application, on the other hand, will create its own ribbon, kind of like how you have your Revit tabs like modify or manage or collaborate. An iExternal application will make its own tab, but an iExternal command is just going to work like a regular add-in. Personally, I don't like to leave my class named as class 1. I know we're just starting, but let's just, let's give it a name. So we're going to rename this. If you right click on class 1, we're going to call it Hello World because that's what we're building. Usually it's best to name your program in a way that you will remember or in a way that someone else who is taking on the project can understand. And if you remember in episode 2, we said that code doesn't like spaces, so no spaces. It's going to ask me if I also want to rename the project in all the references. So everywhere that you see class 1, like here, and if I had other references to that class in my solution, it would update the name from class 1 to Hello World. So I'm going to say yes, because that's obviously what I want to do. And there you have it. It's now Hello World. It's updated. So you don't need to go into everywhere you've called on class 1 to make that change. Next thing we're going to do is to implement the iExternal command. So one thing you're going to learn if this is your first time coding is that it's very important to keep the rules of the syntax, which is if there's a space, you want to have a space. If there's a colon or a semicolon, you want to have a colon or a semicolon. It's very important to maintain what we would call the grammar of coding because you'll find that a lot of the times if you're faced with an error when it comes to coding, it's most likely a syntax error. You probably forgot to put a colon somewhere or put a space where there should have been a space. So that's just a small tip. So we have hello world, and then we're going to say space, colon, IExternal command. Remember to follow all of the Pascal case naming. I'm going to say enter. Now, if you notice, there's a red line under iExternal command, and it's telling me it can't be found because I haven't implemented my references in the code. So I could just implement the references myself because I know what they're supposed to be. But since we're all new here, I'm going to just let Visual Studio help me out a little. So if I say show potential fixes, it's going to tell me I need to implement autodesk.revit.ui, and that's exactly what I need to do. I'm going to click on using autodesk.revit.ui so it's implemented. You can see that it has been updated here. If you wanted to avoid this error in the first place, you should have just put this yourself, but here we are. But if you look at the iExternal command, it still has a red line, which means there's still one more thing we need to do. It's asking me to implement the interface explicitly. The explanation we have here is that every Revit add-in must have an entry point that implements the IExternal Command interface. And you must implement the execute method, which is the main entry point. So without the execute method, the add-in is just not going to run. So we're going to go back and we're going to show potential fixes. And we're going to tell Visual Studio to actually just implement the interface and also bringing another reference which we're missing, which is the Autodesk Revit database. So if I click on implement interface, firstly, my Autodesk Revit database is now being referenced and it has implemented the IExternal command, which includes the command data, the message, and the element set. We're going to go into what these are and why we need them in subsequent videos, but let's just keep going. Let's make our first plugin. Let's get there, okay? So next, we want to update our code to be exactly like the code we have on the screen. I've already explained what results succeeded and the task dialog does in my video where I explain C# in plain English. I recommend watching that first if this is your first time encountering C# because I really do explain it in simpler terms, but we would have to start getting more technical as we become, professional coders like we are. So the first thing we're going to notice between this code and the code that we have on Visual Studio is that our Visual Studio code has an exception. An exception is something that you create as a programmer to limit the risk of your program crashing. So if you've coded a solution for a specific scenario, you want to catch every scenario that's not like that exact scenario. So let's say I made a plugin that returns the number of walls I have in my project. And to actually get that number of walls, there's a certain set of steps I want you to click to arrive at the solution. I need to account for a scenario where someone does something different. And if you've ever worked in an office, you know that someone's going to do something different, right? So the exception catches that. But right now, that's not what we really want our code to be doing. So we're just going to get rid of the exception. All right, so let's play a game. Let's play Spot the Difference. We already have the public class hello world IExternal command. We're missing our transaction mode, which is supposed to tell Revit how it needs to interpret our plugin, whether in an active session or just whenever Revit is running. We're also missing our task dialog, which is supposed to print hello world. And we're missing our return to give Revit an exit point. When the code is done running, we want to know if the result succeeded, failed, or if we need to do something else. So let's start by implementing our transaction mode. I've told you never to copy paste code from the web, and that still stands because honestly, it can be more challenging to fix code that you've copied than not. But since we're still beginners and since we really don't know what any of this means yet, we're still just going to copy the transaction mode into our Visual Studio environment. And if you notice, it needs to be before the class name and not after. So I'm just going to come into Visual Studio and paste it here. You will notice that even though I pasted it here, it created a tab. That's because Visual Studio has something that just keeps your code looking clean. If you're completely new to coding, trust me, the tabs and the spaces, they're just really important. That's how code stays organized, and that's how the code knows what it needs to be looking at. So if you notice, this code is inside these two curly braces and it's indented. And then this code is inside these two curly braces and it's also indented. So any code I put in here is also going to be indented. If you're not working with Visual Studio, you would have to put these tabs and these indents yourself. And that's why it's always recommended to use a very smart and very helpful IDE instead of just coding with like Notepad or something. I mean, if you're hardcore like that, by all means, more power to you. The only thing we're missing now is our task dialog, which needs to go into our external command line. So we're going to type this one. We're not going to copy paste so we can see how it works. So we will know we want to make a task dialog. As soon as I start typing task dialog, Visual Studio has helped me out by telling me, oh, is this what you're trying to type? And then I click on that and I want to call on a method. For those who don't know what the method is, so if you think of a car, you can access maybe its shape or its size, but a method is how you access a function. So you can access how the car drives. The methods are more of a doing. They're more like the verbs of coding, and then the properties are more like the adjectives. It's beautiful, it's fat, it's slim, that sort of thing. So we want to access a method that tells the task dialog to show. As soon as I start typing .show, it's helping me out by telling me, oh, do you want to show the task dialog? And it's also giving me options for the .show. I'm just going to click on show for now because we already know what we want our code to look like. Now, as soon as I type the first bracket, Visual Studio is giving me options of what I can do with the task dialog. I can just show a string title with a main instruction. So in this case, it would just be the title of the dialog, which would be just hello world or Revit or whatever we choose, and the main instruction, which would be just show me hello world. I could also have a string title, an instruction, some buttons, or I could have a result, some buttons, a main instruction, a title. You're able to implement methods in several ways, and when you're working with an IDE that's as smart as Visual Studio, it gives you all of the options for what you can do. We're going to stick with the first one, which is just the string title and the main instruction. So according to the website, our string title is Revit, which you always make strings using parentheses, and comma to separate the title. As you can see in the instruction here, it's title, comma, and then the main instruction, which is hello world. You just want it to say hello world. That's all we want the dialog to do. So we say hello world, and now we need to return a result. If we don't return a result, the code is just going to keep running. It's not going to know when to stop and just exit. So we will say return Autodesk dot Revit dot UI dot result dot. It's already giving me what I want to type, and I can press tab to accept, which I will because we want to save time. And there you have it. So far, there are no issues found. My code is reading well. If you miss a semicolon or parentheses for your string, you would see some issues found here. You would see like a red circle telling you that there are errors, but it's telling us that our code is reading okay. We don't have any issues. And believe it or not, guys, that's it. Now we're ready to build the plugin and open it up in Revit. So to build the program, we need to make what is called an add-in manifest file. This file, think of it like a register. It's something that tells Revit you can open this command. If you watch my video on explaining C# for Revit in plain English, I've explained what each line of the manifest file does, and I recommend you to look into that. The manifest file is a notepad file, and we could create a text file in notepad and just write the manifest instructions, but that's not what we're going to do today. Going back into Revit, we're going to right click on our solution, not the class, the actual solution. And we're going to click on add, and we're going to click on new item. It's already telling us to create a class as a new item, but that's not what we want. So we're going to click on show all templates because that's not what we are trying to create. We want a application manifest file. So when you click on that, we're clicking on application manifest file. You could also do a text-based file like the website says, but this is the way I prefer to create the manifest file. So when you click on application manifest file, it's gonna say app.manifest. Honestly, that's not what we want. Our manifest file is usually a .add-in file type. So we're gonna rename this, just rename it to hello world dot add-in. Remember to add the dot add-in because by default it's going to make a dot manifest file, and that's not what we need because we're not making a Windows Form app, we're making a Revit app. So we want it to be dot add-in. And you click on add, and there you have it. It's there under your solution and it's dot add-in. and you have a lot of XML data that we absolutely do not need. So we're going to just clear everything out. And guys, this is the one instance where it's okay to copy paste code when you're dealing with XMLs, because XMLs, unlike code that's like C# or Python, are really just text-based instructions that you can really just navigate by copying pasting. And what we want to do is to just copy all of this data into that file. You can see it's telling you to save the file as .addin and put it in your addin directory, but with the way we've created it, it's going to build the whole solution, including this file, and place it in that directory. So I'm going to paste, and then I'm going to just clean this up a bit. Remember that the add-in type is a command because it's an IExternal command. If this were to be an application, the add-in type would be an application. If we weren't creating our manifest file in Visual Studio, we would have to navigate to the actual folder where our DLL file is going to be compiled. So when you compile your code from C#, it's going to be its own DLL file. That's how Revit is able to open it up, same way it opens its own API. But because we're going to be building the solution in one platform, we don't need to do that. So what we'll do is instead change this to our project name, which is our first Revit plugin. Make sure that you type it exactly as it's spelled. It's interesting just how much issues in coding are really just grammar and the English language. When that's done, it's going to be able to recognize that this is the solution you're trying to build. Then we're going to create a GUID. So if you think of how Revit elements have unique identifier, so does code. And we're just going to clean this up because it has to be unique. We can't use the same GUID that several thousands of people have copied over from the internet. It's going to kind of confuse Revit a little. So if you go into Tools and click on Create GUID, you're going to see a pop-up that lets you create different kinds of GUID. What we want is just a simple one. So we'll leave it at 6 and say new GUID and say copy, and then click here and say paste. Now, we don't need all of this fluff because that's just not how the Revit manifest file works. So we're going to clear that out. And there we have our GUID. Next thing we need is the full class name. So this is the whole solution name, but this is the actual class we're trying to build. The solution is able to host multiple classes. We don't only need to have just one class per solution. We can have up to 100 as we desire. This is going to be your solution name, our first Revit plugin, followed by your actual class name, which in this case is Hello World. If you remember at the beginning, we changed it from class 1 to Hello World, so that's where that information goes. Text is what shows up when you do like an undo command. If you've ever navigated to the window in Revit where you can see a list of your commands historically so you can undo some of them, the text you put here is what shows up in that. So instead of hello world, so we're just going to leave that as hello world because that's what it is. And then the vendor ID, when people launch Revit and they see your plugin for the first time, they're going to see your name. So here we're just going to say the BIM mentor and your company information. I don't have company information, so I'm just going to put the BIM mentor as well. Typically, you should put a URL to your website because God forbid anything happens to your plugin, an error is going to show up and say, this is the vendor information that we were provided from this developer. This is who you can contact. So ideally, your vendor description should be a URL to a way they can contact you. And we're done. The add-in is done. We're just going to save all. So we're going to save our add-in and also our class. And we're just about ready to compile our code, guys. It's time to run the code in Revit. So there's two ways to compile code. The first is to just build it. and then copy paste the files into the directory that you want it to go. Or you could automate that. You could create a macro in Visual Studio and tell it to put your compiled files into that folder. So to do that, we'll go into our solution and double click on properties. You're going to see a couple of options here. You can change your target.NET framework now if you forgot to do it at the beginning. You can also set up some debug instructions. So debugging is when you want to launch your command in Revit before you've compiled, just to see if it works, to see if there's any issues so you can actually fix them. Now, when we click on build events, we have two types of build events. There's the pre-build, which is something you want to happen before you've built your code, and there's post-build, which is something you want to happen after you've built your code. So we're going to put this macro into the post-build event command line. You can just type it in as it's shown on the screen. I'm going to leave this in a comment below, so you can just copy paste it from there. And it's saying that this should run if the build is successful, or you can tell it to run always. But I think it's recommended to leave it when the build is successful, because sometimes something might be wrong with your code and you don't have a successful build. A build is basically code that has been compiled and it's ready to go, for those who don't know. So I'll leave it at that. If you notice, it's the app data Autodesk Revit add-ins folder. It's not the program files or the program data folder. It's the app data folder, and it's add-ins 2023, which is the version of Revit we're trying to build for. And that's it, guys. We're ready to build. We're ready to compile our code. So I'm just going to click on the green button at the top that says start. And that's it, guys. It's saying that our build actually succeeded. There was no issues with our code. However, there is an error saying that we need to add an executable project to run a class library. A class library cannot be run on its own like a program. What that means is we need to add revit.exe, which is the executable Revit file, to our debug. Usually when code is done running in Visual Studio, it's going to launch the application that it's supposed to be built to. But because we haven't set up revit.exe, it doesn't have anything to open. So we're going to just click OK, and we're going to go to the debug menu to set up our Revit program. So what we'll do is we will start external program, click on browse, navigate to our C drive, program files again, Autodesk again, Revit 23 again, and we're gonna go find our .exe Revit. When you install a software, you can usually see an icon that lets you just open the application. But really what's happening is that that icon is launching this executable file. So you always need this executable file to actually run Revit. So I click on open, and there we have it. It should be able to create our code and also launch Revit at the same time now. Before we actually build our code, we've added our executable to the debug property, and we've added the path that we want the files to copy to. Now we want to actually set the files to copy. So if you click on your class, you should change your copy to output directory to copy if newer, and do the same for your add-in manifest file. Otherwise, it doesn't copy the file, and without the manifest file, you do not have the opportunity to run your application in Revit. So we're going to click Start to start debugging. And you're seeing that it's already launching up Revit itself. And here is our add-in. It's saying that the publisher of the add-in could not be verified. That's because this is not an official Autodesk add-in. This is an add-in that we made. It's saying it's coming from an unknown publisher because we haven't signed our add-in yet. But you can just say load once so that it only loads in this instance of Revit and not every single time you start up Revit. And we want to test it out by opening a test project. I'd recommend making your own project because sometimes the Autodesk sample architectural projects are problematic and unpredictable. And if we go into the add-ins tab and click on external tools, there we are, hello world. If you click on that, you can see the Revit string, which we gave as the title of our dialogue, and you can see Hello World printed out. Thank you so much for watching. You're already on your way to becoming a world-class programmer. In the next sessions, we're going to be building even more complicated programs for Revit. Please like, share, subscribe, and comment. This really helps me a lot, and I'll see you next time.